Hello everyone. In this video we are going to solve the question which came up in the LeetCode Weekly contest 365. The question is minimum size subarray in an infinite array. So let's directly jump into the question. The question states that we have been provided with an array. Let's say the array given to us is 1, 2, 3. We can assume the 1, 2, 3 to be occurring infinite number of times. For example, 1, 2, 3 can be elaborated as 1, 2, 3, 1, 2, 3, 1, 2, 3 up to infinite times. And from this particular infinite array, which can be termed as I array, from this I array, we need to choose a subset, a sub array, sorry. We need to choose a sub array whose sum is equal to the given target. For example, for 5, we can have 3 and 2. So the 3 and 2 gives us the only possible way to get the target 5, and so 2 is the solution. Let's consider a more precise example which will help you to understand the crux of this question. 1 1 1 2 3. So as we said that this is an infinite array, we can assume triple 1 2 3 and so on, this to be infinitely long. And let's say the target given to us is 4. So since the target given to us is 4, so we are required to find the minimum length of the subarray whose sum is equal to target. So 1 plus 1 plus 2 is equal to a target. So from here we can see the size is 3. But when we move on, we are able to see that 3 plus 1 is equal to 4, which is having a size 2, and 2 is less than 3. So the minimum size of the subarray is equal to 2 and not 3. So in order to tackle this question, we have solved a couple of questions in the past where dealing with circular arrays like 1, 2, 3 and 1, 2, 3. If this continues and if the indexing were to be done as 1, 2, 3, 4, 5 and so on. So one thing you might be familiar with is as soon as our original num's array length gets exhausted, the next element like 3 can be referred to as I modulo n. Here n equals to 3 since the size of the array is 3, and c I modulo n is 3 modulo 3, that is equal to 0. So we are able to come again to 1 after the original array gets exhausted. So this concept will be used in the very near future in order to solve this question. But before that, I want you to have an intuition behind the working of the algorithm which we are going to develop. So let's say we are having the same array given to us triple 1 2 3 and so on. The target is given to us. First of all, let's see the sum of the array 1 plus 1 2 3 5 8. Okay, so sum is actually equals to 8, and if target equals to 16, so directly we can say that if this array were to be replicated twice, that is 1 1 1 2 3 and again 1 1 1 2 3, the sum of this is equal to 16, and hence the minimum possible subarray from the infinite array will be this portion whose length is equals to, of course, 10, and the target value 16 is achievable. So here, as you can see, the relation between sum and t is that minimum t by s steps or minimum t by s size subarray will be required in order to reach 16. So 16 by 8 is equals to 2. Let's take another example. This time let's change the value of t. Let's say now the t is 17. Okay, yeah. So let's say the t is 17. We know already s equals to 8. So minimum number of steps to require in order to reach near 17 is like I can do 8 into 2, which is 16, and I need one more element in order to achieve 17. So possibly this can be a solution if I am being provided 1 here. So since 1 1 1 2 3 1 1 1 2 3 and again a 1. So since this subarray is a part of this infinite array, I can say that a size of 11 is able to suffice to the target value as we saw here. Okay, so this 11 size subarray is enough to get the sum as equal to 17, which is the minimum. One thing crucial in this example is like if we are lagging for the value 1, we had found out at the first index only. But let's say uh, I would be requiring 17, 16 plus 5, 21. Let's say the target value was 21. Our third example will be helping us to reach to what I'm trying to convey. Now let's say t is equals to 16 plus 5, 21. Sum was 8, right? So minimum t divided by s, that is 21 divided by 8, which is 2 of course, and 21 modulo 8 is equals to 5. So this modulo value is the remaining value which we need to find from this subarray. So I hope you got this point that minimum two whole arrays will be required. From this two, I mean to say 1 1 1 2 3 and 1 1 1 2 3. This much array or the subarray from the infinite array will be required in order to reach 21, and the remaining 5 must be calculated. So in order to calculate the remaining 5, I had referred to you example already, like triple one two three, and if I'm writing triple one two three again, for the remaining part I'm able to use this circular array concept and use two pointers in order to figure out the minimum possible length in order to reach this remaining value. So possible solution is that first of all our window is going to deliver us a size 4. Then as soon as I include 3, the minimum, the window size will be shrinking, and then I'll be having this. So minimum, I'm not going to discuss about the working of the two pointer approach, which is required to find the minimum subarray which equals to the target value. For the remaining value, we are just going to have this in mind that we are going to use the previous concepts which we have using in order to find the minimum subarray. So for 5, I'm having the minimum length equals to 2. So 2 3 is the minimum length which sums up to 5. So the final subarray from the infinite array which satisfies t equals to 21, if I show you, will be I'll start from 2 3. So it will be 2 3 1 1 1 2 3 1 1 1 2 3. So this portion has been replicated by this, and 2 3 is being replicated to this. So one conclusion major which is drawn, that we can have the minimum subarray from any point, and it is guaranteed that if we are able to find the sum remaining from this array, we'll be getting the minimum windows length, else we are going to return -1. So I'll just walk through the code once in order to make it more clear. So first of all, I'm accumulating the sum, as you can see. Now the minimum size which I'll be requiring is target divided by sum into num size. So since 2 was the output here, so by 2 I mean to say 2 into size of the array 10. So 10 elements are minimum required in order to reach the target value. The remaining is target modulo sum, which gives us the remainder, right? Now, in order to replicate this, in order to solve for this circular array problem, I'm going to replicate the array once more because I do not want to mess up with I modulo n for now. And for simplicity, I'm going to just push back the elements. Now, in case the remaining is equals to 0, I'm simply going to return the minimum size. That is, like for an example where t was equals to 16 and s was 8. So simply there will be no remainder as 16 modulo 8 will be 0. So I'm going to return 2 into 5, that was our minimum size. Now this is the standard way of finding the minimum subarray to find the target value equals to the remaining. As you can see, I'm having the window size minimized. At last I'm going to see that okay, my win was initialized with 1 in I. If this exceeds that, I mean to say that remaining target was not found in this array, so that win was unchanged. And if this so, I'm going to return -1, else I'm going to return the sum of min size and win. So this was the solution. Thank you so much.